I hope you all are good and doing well for the preparation of your upcoming CIEs. Guys, the topic today, what we are going to discuss is about vectors. And vectors are also called directional quantities. Directional quantities. Because in order to justify or describe a vector, we must tell the direction in which the quantity or the particle or object is moving. So direction is very important. For we can also say a movement through a certain distance. For example, we can say a movement through a certain distance and in a given direction given direction, because movement through a certain distance in a given direction is called, you guys know well, a displacement. And in math we can say this as or a translation. And before we going to get the detail of this factor, here for the AS level we will discuss only 3D, three-dimensional vectors, three-dimensional vectors in three-dimensional. So three-dimensional vector we have to discuss here, because two dimensions are related with the O levels, and this lesson is going to be made only for AS level. So we call this a translation as well. So displacement or translation is the same thing. For example, suppose a particle is lying on a plane. Well, we are saying it's three-dimensional plane, right? In three-dimensional plane is like this. This is the point of origin where the three axes cross each other. Suppose this is x coordinate here, here the y coordinates, and here the z axis. So, and generally we represent the moment towards the x direction, x axis is with the unit vector I, and is j, and here z for k. The general terms associated with their movements along x-axis, y-axis, and z-axis in three dimension. And this means this is a unit vector. You know what means unit vector? Unit vector is the one whose length or magnitude is 1 towards a particular direction. So the unit vector is the one whose magnitude or length is 1, right? Guys, generally we used to represent a vector, and you can say how to represent a vector. Generally it is represented with a bold letter, yani a bold letter, like you can write this A with the in the bold form, or you can write A with the bold form, small capital, right? It must be bold, or you can write, sorry, in bold letter, in or with a letter having an arrow head above or below of it, below of the letter. Below of the letter. Like example, we can say you can write a letter, put an arrow above, or a letter with an arrow below, or same, it can be with capital A, B, C with an arrow above or below it, right? So this is how to represent a vector in. Now guys, we need to know about if a vector is negative of vector. We can say negative of a vector. What it means? Suppose a vector A is moving in this particular direction with a magnitude, say its magnitude is 2 unit, right, towards this direction. So we can say the negative of A is a vector. Negative of vector, we can define a vector having same magnitude but in opposite direction. Like here you can say you can have like this, a negative of vector A is this in opposite direction but having magnitude what, -2 unit, because it is moving in the opposite direction. I hope it is clear. Fine. So we can say for vector AB, you can say it will be -BA. If you change the pattern, yani A to B, like if you start from here, suppose a point A and point B, and this is vector AB, or you can write vector AB going in this direction, so it will be equal to the other vector, sorry, let me draw it again, BA with a negative sign because of it is moving in the opposite direction. So you need to be very careful. One more important thing before we start the questioning and the pattern, you guys need to know in 3 dimensions. Says we have this one, x-axis, y-axis, and z-axis. Says x is here, y is here, z is here. Along unit vector is I, it's j, it's k. If we have a vector like which is lying in the plane, 3-dimensional plane, say here, right? So suppose this is A, this is B, and here about the origin, this is point vector B that is lying in between x, y, and z, and it is lying in the plane. Like you are sitting in the room, that's the plane. In between the room from all 3 axes, you have the distance from all the 3 components of x, y, and z axis. So we can say vector AB can be written as the position vector of B, that is always OB. We always take the position vector of any vector from the origin O. So OB minus OA, right? OB minus OA, that is the vector AB representing from how OB minus OA, and for this case OB we call position vector of B from O, right? And OA position vector of A from O, origin, right? So that's defined. This is yani O, A and B, OB. Like this is B is here, OB, and this is A is here, so it's OA. And the line which joins A and B, this is black one, this is AB. And you need to join or draw the lines by keeping head to tail rule in your mind, right? What you have done in physics. So it means for BA, this can be written as from position vector of OA minus position vector of OB, right? So you guys need to be very careful about the direction and the position vector. Position vector tells us the position or the location of a point with respect to origin O, right? Now we are talking about the parallel vectors. Parallel vectors, as clear from the name, two vectors are said to be parallel if one vector is a scalar multiple of other. Like in mathematics, we can say there are two vectors, suppose A and B. I can write vector A, I'm writing in bold letter, vector A is equal to generally lambda, we can say lambda Greek letter B, vector B, and this lambda is called scalar multiple, right? This we call scalar multiple of this vectors, two vector A and B. Yes guys, so we have to show this, or you can write this the whole expression as with a small letter with the arrowhead, or lambda B vector is the same, like, right? So two vectors said to be parallel when they have the scalar multiple of each other. We can take the example. Suppose you have a vector A, you are given any example, given vector A has 1 2 3 and vector B has coordinates like 3 6 9. You can see here vector B can be written as the multiple. If you can take 3 common from the vector B, something is common, some number is common, that is 3, 1 2 3 is left. So we can say any one third of any one you can say the one vector b is equal to 3 times of vector a, right? Vector b is 3 times of vector a. So we can say scalar multiple for this case, scalar multiple for above case b is equal to 3a is 3, because that is lambda. But if you few students can write it as, or you can do this, you can write a in term of b, so lambda b. If you want to write like this, then you need to divide b with lambda. So you can say a is equal to 1/3 of b. Therefore here for this case a is equal to lambda b, we can say lambda is equal to 1/3. Scalar multiple is 1/3. So you guys need to be careful about in which order you are writing. You are writing from b to a or a to b, and accordingly you can change the scalar multiple lambda. I hope it is clear. Now addition or subtraction of two or more vectors. Suppose we have two vectors like a having coordinates, say is a b c, and another vector b having, don't confuse about this and this. Okay, I will change. Suppose it's a vector p and here vector q, right? Labels, this is dummy variables, you can label with any name. Say it's x, y, z. We have two vectors and we want to add or subtract them. So vector a, p plus vector q, once you are going to add them, do write them in any order. Any p plus q is the same as q plus p, and you need to add the respective components of both, yani a plus x, b plus y, and c plus z. This is how we can add. So it is same as if you can add q plus p. So we can say that vectors addition is commutative. This word commutative describes commutative. We can write because a plus b2 vector addition is the same as b plus a, so it doesn't affect. So you can say vector addition is commutative. I hope it is clear. Next beta we can go by the subtraction of two vectors. Like now we have to subtract vector p, but the same case p minus q. What to do? Do write the components of p and minus components of vector what is that, q, x, y, and z. We suppose it. So once you will minus it, the respective components will be minus with the respective, and we get this one. But here you can see this is not equal to as q minus p. So we can say vectors subtraction is not commutative because 2 vectors A minus B is not equal to B minus A. I hope it is clear. Right, guys. So far we have discussed about the basic concepts of vectors, definition in 3 dimensions, how to represent a vector, negative vector, parallel vectors, and their applications, addition, subtraction of 2 or more vectors. So the rest we will discuss in the second video. Bye.